Atoms bond because they move towards stability, much like the noble gases. For many atoms, that means reaching 8 valence electrons, the octet rule. For hydrogen and helium, a full first shell means just 2 electrons, the duplet rule. These targets help explain both ionic and covalent bonding. So far, we've seen that valence electrons control how atoms combine. The octet and duplet rules now give that idea a clear goal, a complete outer shell. We'll use that goal to make sense of ion formation, ionic bonding, and covalent bonding. An atom is most stable when its outer electron shell is full. Noble gases such as helium, neon, and argon already have full outer shells, so they rarely react. Many other atoms do not, which makes them less stable. Bonding helps atoms move toward a noble gas-like arrangement by gaining, losing, or sharing electrons. Noble gases provide a useful model for stability. Helium is stable with 2 electrons because its only shell is full. Neon and argon are stable with 8 electrons in their outer shell. For other atoms, the goal is not simply 8 by itself. The real goal is a full outer shell, which often matches a noble gas configuration. The octet rule helps predict why many atoms react. Most become more stable when their outer shell has 8 electrons. Sodium has 1 valence electron, so it can become stable by losing it. Chlorine is 1 electron short of a full outer shell, so it becomes stable by gaining 1. When sodium transfers its electron to chlorine, sodium becomes a positive ion and chlorine becomes a negative ion. Their opposite charges attract, forming the ionic bond in sodium chloride. The octet rule works for many atoms, but the first electron shell is different. It can hold only 2 electrons, so atoms using this shell are stable when they have a pair. This is the duplet rule. Helium already has a full first shell with 2 electrons. Hydrogen has 1 electron, so it tends to gain, share, or pair with 1 more electron to reach a stable duplet. For atoms like carbon and oxygen, stability often means an octet, 8 electrons in the valence shell. Hydrogen and helium are different because they use only the first shell, and that shell has room for just 2 electrons. Helium already has 2, so it is stable. Hydrogen has 1, so it is 1 short. When hydrogen shares or gains 1 electron, it fills its first shell. The duplet rule is not a weaker octet rule. It is the correct stability rule for the smallest atoms. There are 3 main ways atoms complete their outer shell. A metal atom may lose electrons, forming a positive ion such as sodium Na+. A nonmetal may gain electrons, forming a negative ion such as chloride Cl-. When oppositely charged ions attract, an ionic bond forms. Atoms can also share electrons instead of transferring them. A shared pair helps each atom become stable, creating a covalent bond. In most cases, stability means an octet. For first shell atoms such as hydrogen, a duplet is enough. Covalent bonding happens when atoms move towards stability by sharing electrons. In hydrogen gas, each hydrogen atom has 1 electron and needs 2 for a full first shell. By sharing a pair, both atoms count 2 electrons and become stable. Chlorine follows the same idea, but with an octet. Each chlorine has 7 valence electrons, so sharing 1 pair gives both atoms 8. The key point is that shared electrons belong to the bond, and both atoms benefit from them. Hydrogen shows the duplet rule clearly. Each hydrogen atom has 1 electron in its first shell, and that shell is stable with 2. Instead of one atom giving an electron away, Two hydrogen atoms share their electrons. The shared pair belongs to both atoms, so each hydrogen effectively sees two electrons. That shared attraction holds the atoms together as an H molecule, a simple covalent bond with a stable duplet. In an exam answer, always connect the bond type to stability. In ionic bonding, sodium becomes stable by losing one electron, while chlorine becomes stable by gaining it. This produces ions with complete outer shells. In covalent bonding, electrons are not transferred, they are shared. Hydrogen can count the shared pair as two electrons, completing its duplet. Chlorine can count the same shared pair in its outer shell, completing its octet. The key sentence to remember is shared electrons belong to both atoms for the purpose of stability. Covalent bonds bring stability without producing charged ions. To summarize, atoms become more stable when their outer shell is complete. Most atoms follow the octet rule, while hydrogen and helium follow the duplet rule. Atoms can reach stability by gaining, losing, or sharing electrons. Losing and gaining electrons forms ions and often ionic compounds, such as sodium chloride. Sharing electrons forms covalent molecules, such as hydrogen. Next, we'll build on this by studying ion formation and ionic bonding.